Hello, welcome to today's webinar where we will be reviewing RAD Server including the features and benefits, and then we will walk through a real-world use case scenario utilizing the capabilities of RAD Server. My name is Brandon Schopp, and I am the Senior Director of Products, and I will be joined today on the call from David I. and Jim from the Technical Evangelist team, Serena and Marco from the Product team, and Al and Powell from the Technical Sales Engineering team. RAD Server provides enterprise-class functionality without breaking the bank like other offerings in the space do. Leveraging either Delphi or C++, you can build and deploy your backend services and expose them via REST endpoints for your application to connect and interact with, even if they are written with our product or not. As an example, if your application is written in C#, C++, or even Node.js, if it can interact with REST, then RAD Server can work for you. We have broken this down into three areas: REST endpoint publishing, integration middleware, and application services, each of which we'll walk through in more detail. As you know, building a full-featured, multi-tiered application is very involved and encompasses many different pieces. RAD Server makes this task easy by providing out-of-the-box and easy-to-use capabilities. You start by originally creating the application itself. You then need to integrate with the backend server via API endpoints, as well as integrate it into further backend services like databases or IoT devices. Next, typically you're going to add your application services, including adding users and user permissioning. You then deploy and manage your application on an ongoing basis. The REST JSON endpoint creation enables RAD Server to work with almost any application technology. Control who can access what functionality and which APIs quickly and easily with user access controls, including the ability to integrate with LDAP. View usage tracking and analytics of endpoint API usage to better understand how your end users are using your application and which part of the application are the most heavily utilized. With our FireDeck technology, quickly and easily connect to most databases, including commercial offerings from Oracle and Microsoft, to open source offerings such as PostgreSQL. Easily integrate and snap in other products you may utilize for cloud storage from Amazon, for example, social media like Twitter or Facebook, or backend as a service providers from Google, Amazon, Facebook, Kinvey, Parse, and others. If your use case requires the need for interaction with IoT devices, then RAD Server has you covered as well. RAD Server also provides key functionality and services to power your applications. For example, push-based notifications and user and group management are quick and easy features to leverage. We also provide our award-winning Interbase database for built-in and secure storage. With our beacon fence technology, we can support proximity awareness use cases to track user movement whether they are indoors or outdoors, and following as they enter and exit beacon zones. So RAD Server encompasses multiple products and technologies to enable turnkey application servers. This includes our EMS technology, Beacon Fence for proximity location awareness, ThingConnect for IoT, as well as ThingPoint for IoT. So for those of you familiar with our EMS product that we have previously offered, you could see a table down below which lists out side by side what are the differences between RAD Server and EMS. And the big things that you'll notice here is, one is the price point is before at $99 a user, which is still the same with RAD Server, but we now have $5,000 for unlimited users for a single site as well as multi-site offerings. And the fact that the IoT and location proximity are included in RAD Server. So going forward, the EMS product itself is essentially deprecated. It is now folded into RAD Server. If you're interested in trying the product yourself, how do I get a trial? So RAD Studio 10.1 Berlin offers a 30-day trial which has a 5-user limitation and is for test deployments only, and that is available today. If you wanted to, you can contact your partner or sales representative with Embarcadero, and we also offer longer evaluation options. We have one that is available for 90 days and can be deployed for production, but the server must be restarted every 12 hours. Most folks have been to a department store. If you're from the United States, you likely have been to a Walmart or a Target, and if you're outside of the United States, there are other stores similar that have departments for things like groceries, toys, clothing, etc. In this webinar, we wanted to walk through a retail real-world use case scenario using RAD Server. In this scenario, the retailer provides consumer-targeted mobile apps for shopping, but also interacting with customers as they navigate throughout the store. Utilizing interactive end-cap displays as shown on the right, along with IoT technologies and beacons to personalize their shopping experience. Push notifications allow for in-store coupons that consumers can leverage during their shopping trip.
This is a quick overview of the architecture and vision for the retail demo we've put together for RAD Server. There's two parts to this. There's the RAD Server itself, which is the back end, and then we have the FireMonkey multi-device client application, which the customer will use on the front end. It'll run on either iOS or Android, and actually could run on Windows or OS X as well, but they're not quite as portable. So when the customer fires up the application, the first thing they're going to do is log on. And this is going to validate their credentials against the EMS database. Now, you could use an external validation system, whatever system you have in place that you want to validate your customers against, or you could just assign your customers a unique ID, and then the customer never has to mess with the username and password. It just validates them automatically when they connect. So there's lots of options available to you for how you want to validate your customers. Once the customer is validated, though, the application will request specials for the store that they're at from the RAD server. The RAD server will pull these details from a separate database that contains information about the retail store. While using the application has a beacon fence map embedded in it. In this case, we're using a hard-coded map, but that map could easily be downloaded when the user connects to include updates to reflect changes in the store, or if the user is visiting a store they've never visited before and that was perhaps created after the app was released. That can be downloaded dynamically. So now the user could use this as a map of the store to help them find things, to navigate the store, find the products they're looking for. But also what we're going to demonstrate here is that as the user enters different zones, so different departments in the store, we will send a notification from the client application to the RAD server, letting the server know what zone they've entered. And then that will give the server an opportunity to respond by sending down specials for the zone that they're in. And also, in some zones, we're going to have a light that's going to come on to alert the customer to a special offer. So as the customer enters the zone, when they get near this light, it's going to come on so that they can see what fantastic offer we have available for them. The lights can actually be turned on from the client application, and that's because we're hosting the server in the cloud, and it would require a VPN connection from the cloud down to the client application, or down to the local IoT devices in order to do that. Could have been possible, but our IT department didn't want to put that together this quick. Another option as well would have been to set up a local server that could then relay the information via another connection going outgoing. But again, for simplicity's sake, we're just going to activate it via the client application, which you may want to do in your situation as well. So lots of options for how this is going to work, but this is one example here. So the light's going to kick on, and then after either an elapsed timeout or when the customer leaves the sales zone, the light will turn off because we want to have it ready to turn on again when the next customer arrives. Another feature we added is for the customer to have the ability to scan a barcode or to search for products by SKU or text. And that will give them the ability to look up product information and price information as they're shopping. This can also actually be connected to the beacon fence system to help them navigate to the location in the store where the product is they're looking for, if they're searching by text. But if they are searching by product and they find the product they're looking for, they could potentially also buy that product right through the application. Lots of options here to see what they're doing, to include special offers for customers, if they have special discounts, etc.
David I here. I just want to spend a quick moment taking a look at the data model for this department store RAD server application. We've got a stores table with some different department store addresses and store numbers and store names in it, as well as a layout of the map of the store on the inside for the different departments. We've got a department table which has the department name and department ID, for example, the toy department, the groceries department. We've got our customer table with customer information, and we have the EMS ID, which relates the customer in the department store database to the RAD server user entries. We've got a products table, which has the different products that you'll see in the demonstrations. And then we've got a beacon fence for departments and the fencing around those departments. And then we have an offer table that as you move into either a fence area or you're near a specific beacon, you'll get information and a special offer, for example, on your favorite breakfast cereal. And that's a quick look at the data model for the department store database that we're using in this RAD server launch demonstration. All right, I'm here with Al Manarino, one of our great field evangelists out of the New York area. Al, welcome to the webinar.
Thank you, David. Happy to be here.
And Al worked on part of the EMS backend, the part of EMS that is going to get the sales product items when the customer gets near an area of the store. I just want to spend a few minutes with you, Al, talking about how you implemented your part of the EMS server. So why don't you tell everybody what we're looking at here?
So thank you, David. So one of the key items with RAD Server is being able to have REST endpoint publishing for your APIs. So RAD Server is an application server for your backend, for your Delphi or your C++ building code. So you put your Delphi or C++ code into RAD Server, and it's going to create manageable REST endpoints. So what we're looking at here is we created a new EMS package that we're calling Get Sales Zone. And on here, we have a data module, and on the data module, we dropped a FireDAC connection component. And if you look at the FireDAC connection component, here's where we connect to our backend data source. So in this case, we're connecting to an intrabase database, and there's the name of the file. And we can click on the test button to make sure we can test and connect to our intrabase database. So connection is fine. And on this data module is now where we can store some queries that we want to run against the database. So the first query we have here will go against our products table and bring back SKUs that are like 231. So there's the 3 SKUs that come back from this, or 3 products that come back from this SKU. And the second query would be daily specials. So when we run this query, it will return back the daily specials based on the store we are in. So now what we want to do now is we want to create endpoints that will run these queries and return the data back. So here we created a resource name called trigger, and we have an endpoint called get sales zone. So as David mentioned earlier, this endpoint is going to be used when the client, for example, a mobile app, enters a beacon fence sales area or zone. And then the client app will call this get sales zone API, and the client will pass the zone location of the retail store. For example, maybe they are in the cereal zone area of the retail store. And then we want to return back to the client all of the sales items from the sales area zone. And as you look through how we implemented this API, for this API we're making use of the TJSON text writer class that represents a writer to serialize the JSON data. And as you see here, if we walk through it, we're going to call that FireDAC query that we just saw earlier, that enter sales zone serial. We're going to call the FireDAC query enter sales zone serial that we sort of defined on this module. And then the JSON writer reference and pointing it to this JSON body, JSON writer. And that's going to put the results into a JSON object. So we run through the query and we return the rows, and it gets all returned back as a nice JSON object. And then we take that JSON object and we pass it to the colon client.
So now we've got our EMS package file. How do we connect that up to our EMS server?
Great question. So when you first create your EMS server, there's an EMS server.ini file that gets created, and there's a section in there that allows you to load these individual packages into the EMS server. So here's the get sales zone BIPL package DLL file that we created, and here's how you load it. So then other folks can create their own REST APIs and create their own packages, and you'll add them to this list. And then as EMS starts, all of these packages with all of these REST API endpoints will get loaded inside of EMS server.
Let's go here and start the EMS dev server we're using for development, right, Al? And then we have a production server as well?
That's correct. So EMS, as you see here, is either a Windows 32-bit or a Windows 64-bit application, and you start it up from command line. EMS development server shows up, and as you look at the logging output, you see it creates this EMS server.configuration file, the INI file that we're looking at right behind it. We see that we're running a licensed version with 5 users max that we can use and test with. And then we see our endpoint got created. We have a resource called trigger and an endpoint called get the sales zone. So now we can now test running this endpoint right from a browser. So if we open up a browser and we pass it our resource name of trigger, and how we implement it or how we architect this application is the mobile client as it's walking through the retail store, as it enters a beacon fence zone. If it's in the whatever zone it's in, we want to pass a string value for the zone it's in. So if it's in the toy department, we want to pass a string toy. If it's in the cereal department, we'll pass a string cereal. So for example, if we were in the cereal department, we want to pass that string cereal back to the EMS server, and that kicks off running that query that returns the cereals that are on sale for that zone. And here's the 3 cereals that get returned from our database, and this information gets passed back to the client to look at and decide if they want to participate in any of these sales.
In the development server, we're just getting logs of things that take place as the endpoints are accessed from whatever, whether it was one of these console applications or from a mobile or desktop client. We would see a log of those showing up.
Open up the console. We also give you this nice management console. You can log into it with console user and console pass as default. And here we have access to all of the users, any of the groups that we have, installation, edge modules, resources, and analytics. So analytics tells us how folks are using the application, what endpoints are they going after. So for example, if we go under user analytics and look at users total calls, or user API calls, we'll see all of our resources and all of our endpoints to give us an idea of how people are using the application, what endpoints are they going after, what APIs are they calling.
Okay, Al, thank you so much for taking this quick look, and we'll move on now to looking at more of the implementation and use of RAD Server in this department store application. So Marco Cantu also worked on the department store application that we're showing you today. Marco worked on some of the endpoints in the RAD server that's part of this department store application. So Marco, why don't you talk about what you built, and then we can take a look at it in action.
Yeah, what I've done here is just create a skeleton application that lets do a couple of different queries against the database data, and convert that the information that's filtered in the query into a JSON format. In this case, it's a specific JSON format for that FARDAC uses internally. So the point would be making it very easy to return a JSON structure that later will be easy to re-import into a FARDAC main table. And at that point, you'll be able to do local queries or processing or bind it to the user interface as needed on the client side. So the components here are just a FireDAC connection that's hooked to the interface database. And then there are two queries that basically are relatively simple SQL queries. We can open one of the two to see the actual code, but the code is actually fairly trivial.
And if we look at the code of the endpoints, I guess here you've got your resource is called item. Is that right?
Yes, I have two resources. One is for returning the entire data structure, a list of items, a list of elements. That's what you generally put attached to a GET endpoint. And then the second endpoint actually returns an individual item. So that endpoint has a further parameter, and it's triggered when the URL is item / and then some ID that is passed to the code, and then the code can use as to replace a parameter in the query itself. Basically, for each individual item in the database table, you are mapping to one specific URL from the client. So the client calling the URL, passing the item ID, and then gets returned. And then the code does a very simple streaming of the content of the query into JSON format and returns it.
Okay, so we'll run without debugging, and that will start up the RAD Server development server. Here it is, reg resource item, right? It has two endpoints, get and get item.
Yes, and then the task that we can do from that point is to open the browser. By default, it opens version check, but using /item as URL parameter, you'll end up seeing in the browser the JSON structure that's returned by that server-side code. And that same data structure is consumed by the client application. And basically what it does is rebuilds as I was mentioning, a FireDAC mem table. Then it's ready for you to use within the client any way you like, tying to a UI, doing processing, doing local storage. Once you have the data in that format, it's very simple to process on the client side.
Okay, and then you mentioned to me that you built a little test client as well.
The client is done kind of on purpose with very, very little code, but just using all of the components tied together. And again, of course, in the real world scenarios, you might want to add extra code and extra information to customize. It's certainly very nice, the ability using RAD Server and the EMS endpoint APIs capability to be able to really simplify the development of the code. We had to write like a few lines on the server. There are even ways to reduce that, and we can write a few lines on the client, but the code needed is really minimal. And there are ways on EMS client to hook directly with FireDAC data. So that makes the development of the client side also very straightforward and very simple.
So if I run this and I just say, for example, get all, there's the grid of the products, for example. And then I can just put in a SKU code in the edit box and hit get button by SKU ID, and then I get the specific product in the product list there as well. Marco, over here on the client side, it's not much special to say about this, right? You just take the edit box of the get by ID.
Yeah, you pass it as a resource suffix that basically means the following element of the URL, so item / and that element that gets properly encoded, and then you execute the REST call. The information you get back on the client, if you look at the first button one click, that in that case I'm using a FireDAC client, a specific FireDAC EMS client, so it's completely hooked automatically. There's no extra code. In the second case, I'm using a regular REST request and REST response. So the REST response, I need to grab the content, which is a stream, and load that stream manually, with one line, into the FDMem table. So in the first case, you can connect all of the components and have the same behavior automatic, or you can just write that single line of code, which is the reverse of what we have written on the server. The server was take this query, save it to a stream, and here is load the stream into a mem table. So it's exactly symmetric code.
Well, thank you very much, Marco, for taking us through the EMS endpoints that you built into the department store app and how this client can use the power of FireDAC and the power of talking to RAD Server to present a user interface.
Okay, thanks.
Now, Serena DuPont is going to show you the user interface and the design of the user experience. So take it away, Serena.
Here you can see our retail shopper application, and this is an application where we're just using a single form and 6 tabs. So you can see we have a tab control that is aligned to the client, and it has 6 tabs. Now we're using the tab position none option, and this allows us to use each of the tabs as a view, so to speak. And in this case, we have a home screen, which is a very common UI paradigm that you see in retail applications because it puts all the focus on one area within the application, making it really easy for customers to find their way around. So for example, here, all the focus is on 4 key functions that you want the shopper to focus on. The ability to search for items, the ability to scan items, find in-store deals, and also view special offers. In addition, there's also the ability to log into the application. So we have a tab control with tab position set to none, which you can see here with the 6 dots at the bottom. Each of these dots presents one of the 6 tabs. So this is the first tab, is the home screen tab. The second tab is our in-store deals tab, and this presents deals close to your aisles. So it's going to show you deals that are available close to your location within the store. It will show the particular discounts, for example, 30% off, and it will show the distance to that particular item. The third tab allows you to search by product name or SKU. So this is another common scenario we've probably all run into. You're in a store, you pick up an item, and you can't find a price tag. So search by product name or SKU allows you to easily search for that item by product name or by entering a SKU number, and then it will return the price for that particular item to you. Now, tab number 4 allows you to search by barcode. So this enables you to pick up the item that you're interested in, scan its barcode, and it's going to return the product name and the product price for that particular item. Tab number 5 shows you all the special offers in the store, so it's going to return a product name and a price. And then tab number 6 is our login tab. So this application assumes that you're logged in, and this is the login tab, which is also linked from the home screen as well. So each of the tabs are linked from the home screen, and that includes the login. So if you have a look here, we have a login button, and we just have set up an on-click event that brings up the login tab, sets that login tab to active. And as I mentioned, the application assumes that the user has logged in, and then will return different offers to them based on their location in store, allows them to view all the deals in the store, allows them to scan an item using its barcode, or enter information about the item and return pricing based on that using the search functionality. You could also easily use the T-Multiview control, for example, to add a slide-in drawer to this if you wanted to have options like account settings, past purchases, shopping history, other deals you might be interested in, etc. You could easily add the T-Multiview control to present a slide-in drawer. It's another common UI paradigm, specifically in mobile applications. So another thing that we did here is we set a custom color for this tab form. So we went to the form itself and then selected fill color, and we chose a custom color. So this is the yellow color fill that you're seeing here. This is an optional setting, of course, but I thought it gave the UI a new nice custom look. And then we're also set a custom color for both the toolbar, the actual toolbar label, and the button. And so for the toolbar here, if we have a look at toolbar 1, there's a tint property that you can select, and the tint property allows you to choose a custom fill for that toolbar. There's also a tint property for the button itself, so we set the button tint color to the same tint color, or to the same color, I should say, as T-label, so that we have a nice custom cohesive color scheme. So let's have a look at the home screen layout. As we can see here, we chose a grid panel layout, and this allows us to give even weight to each of the 4 panels here, and this makes it really easy. It scales very nicely across the different form factors, and as you can see, we have 4 images, all the same size, and we have 4 text labels that are all the same font size. So we have the grid panel layout, and then we have 4 layouts that are part of that layout. We have the barcode layout, we have the search layout, we have the special offers layout, and we have the store deals layout. And if you have a look here at the control collection, we have 4 different grid panel sections. We have column 0, column span 1 is the search panel. Then we have column 1, column span 1 is the barcode. And then we have column 0 here. If we have a look, column 0, column span 1, which is the in-store deals. And then we have our special offers for the last column. And if we have a look here at the column collection, you can see that we set the value to 50%. So each of the columns takes up the same amount of space. So this allows you to create a really nice grid pattern for a home screen layout using the grid panel and using additional layouts as well. So let's have a look at the second tab. So here deals close to our aisles. So some of the things that we've done here is we've set a custom color scheme. We have the top aligned toolbar, then we have another toolbar. So let me show you here. We have the list header toolbar with 3 items. We have 3 labels: the product name label, the discount label, and the distance. And then we're using a list view control. And we've customized the list view control. So we have a look here at our item appearance. We're showing the detail, which in this case is the discount, the text, which is in this case the product name, and then on a button we're going to show the distance to that item. And one of the things that we've done is we've color matched the text that represents the product name, the text that represents the discount, and also the text that represents the distance to that item, so that it has a very nice cohesive look. So if we have a look here at text, we've matched it to royal blue, which is also the custom color that we chose for the product name. For detail, we've switched it to crimson, which is a shade of red, and we've done the same for the header toolbar label here, etc. Now let's have a look at tab 3. So tab 3 allows us to search by product name or SKU. It's also using a list view control. So if we have a look at some of the settings here that we've selected, in our search list view, we're using the image list item right button. This allows us to show a photograph or an image of that particular item within the store, plus the item name, and then we can also show the pricing as well. In this case, we've set a custom height for the item, for each item, so we have more space for it. And we've also selected to use the built-in search functionality as well. So here we have the ability to easily search within the list by enabling search always on top and search visible. We also have the option to switch between control type styled and control type platform. So if you select control type equals platform, then on iOS for T-List View, the control is going to be rendered by the underlying operating system, and on Android it's going to be rendered by FireMonkey's GPU-driven rendering. Now let's go to tab item 4. This is our product barcode. We've set up an area here that represents the barcode scanner, and we'll see that in just a little bit. And then we also have, for tab 5, we have just the same color that we're using throughout all of the different lists that represents a product name. So you can see here on tab 5, we're using the same royal blue as we're using on tab 2. So this is, again, just a subtle way of showing the user that they're easily able to identify things like product name, discount, etc. by keeping the color patterns the same. And then tab 6 is our login screen. We have an item here at the top, and let me just scroll to that. We have a layout, and we have our input controls. And as you can see here with the input controls, we also have set a text prompt to indicate to the user what they're supposed to do. So the first field is the username field, and then the second field is the password field, and then they can log in. Now, if we have a look here at the back button, we're also using a built-in action that allows you to automatically slide back to another tab. So in this case, we're using the change tab action, and this is done using the action list component. So we have an action list component here, and all we had to do is select our back button and selected the new standard action tab, change tab action. And then what we've done is we've selected the slide transition. You can either choose no transition or slide transition, and we've selected the target tab as the home screen tab. And so this will give you a nice slide transition as you're navigating back to the home screen tab. And as you can see here in my application, I'm using some sample data. So this is a really great way to quickly prototype your application. There's a component called tPrototype bind source, and via the right-click menu, you can easily add fields. You can shift select to add multiple fields. So I've added several different fields. And then I'm using the Live Bindings Designer to connect my list view control to my data source. So if you go to View, Live Bindings Designer, you can see here, as if I refresh this, that I've connected each of my list views to my sample data. So for example, here I've set up the prototype bind source, and it's connected to my in-store deals. And then of course in the actual application, it will be connected to your data source. But this allows you to quickly prototype your application, and using a Live Bindings Designer, it's very easy to quickly connect your application to your data source and your different UI element.
I'm going to show you how the barcode scanner works. For this test, I actually have a local instance of the EMS server running here. I've installed a modified version of this provider here that has a get item that takes a item ID and passes it here to this query that's going to do a query select star from products where UPCA barcode equals code. So whatever code I got, I'm just going to look up whatever matches that product there. Now the barcode scanner I'm using, what it is, it's a port of the zebra crossing barcode scanner. It's an open source barcode scanner library. It's been around for a long time, lots of platforms. This is a port of the C# for .NET version to Delphi. Both versions use the Apache license. If you're not familiar with Apache, it's a very permissive license, very easy to use. You can easily integrate this in your applications, but talk with your legal department before doing that. One note is right now it supports Code 128 and QR codes, which I think are the two coolest codes, except that product codes are UPCA codes, which are actually a different type of barcode. They are in the process of working on barcode UPCA codes for products. That will probably be available in the near future. It's just not available right now. So definitely check out this if you're looking for a barcode solution in your application. The great thing is it's all native Delphi code. So in my application here, I just use the camera component, and I'm going to scan with that camera component. Just like if you use the camera component anywhere else, you're going to use that, and it's going to have the sample buffer ready, and we're going to call get image using the thread synchronize here. And so this line here is exactly the same. We're just grabbing that buffer image, putting in the bitmap on the form, which if we go back here to our design surface, go to our scan tabs. Let me hide these other icons here. We're just going to replace this image here with whatever the current scan is. And then we take that bitmap and we pass it right here to our scan manager. So the scan manager is the object we create from the barcode scanning library in order to see if there's a barcode. And it's going to go through and scan that. And if we get a result set, then here we're going to take that read result and pass it to this add item routine, which is just going to pull out the information from that result set. Actually, we'll go jump to that here. And it's going to call, this is the EMS service, get by ID, which I just showed you. It's going to pass in that ID, which is the barcode, and get back the name and the price. And then it's going to construct a list box item to display that information to the user. So I can show you the implementation of the call here in the client application. And we see here all it is doing is using the backend endpoint, sending it the ID, executing it. Then we just take that stream, pull it apart, and we get the product name and sale price out of it. And we set those in the return. Make sure they'll only receive one record back. If not, then we set the result set to false, saying either I got 0 or more than 1, neither of which should have happened, and return that error. So there's not a whole lot of really complex code here. It's pretty straightforward, pretty easy to work with, I think. Most of the code relating to the barcode scanning I actually got from the sample application, and most of that I recognized as coming from the camera component application that we ship. So not rocket science here. If you've worked with the camera component, you can work with this barcode scanner. So let's take a look at the barcode scanner here in action. Here it is running on my Android phone, and I'm going to hit barcode scanner here. Now there you go. It scanned the barcode, the first barcode. I just have some paper here with the barcodes on it. These are 128C barcodes, which are numeric only 128s. So they're narrower. They're not as big. So they're about the size of a UPC code. But like I said, soon we'll have UPC code support in there, I'm pretty sure. So there we go. We scan that first barcode. We'll scan the next barcode here. We got the Barbie Careers Chef doll and the HP Office Jet printer ink package. Honey Nut Cheerios. And Frito Scoops. Is it scanning this? There we go. Sometimes it's like boom, boom, boom. Other times it's like, oh, didn't quite get it. But if you move it in and out a little bit, usually gets it. So we see it's got the Frito Scoops. And now we'll do the Barbie's Career Pilot doll. So there we go. This works great. It works even better on QR codes. These barcodes here are 1 pixel width, and I found that I had to have the torch on, the light on the back, which is pretty easy to do with the camera component. So you can, I don't know if you can tell that the light's on there, but it is. If you don't go with the 1 pixel width barcodes, then or if you go with the 2 pixel width barcodes, which is what this one here is, then you can do that without the light, but that's a pretty wide barcode. So if you want to get the 1 pixel width barcodes, which is a pretty small barcode, then you need to have the torch on, or make sure you have really good light. So there we go. I got 2 of them there in that one. Anyway, very cool, easy to use barcode scanner. It's going to grab this information, send it to the RAD server, collect the data back for the customer, and display it to them here. So I could easily add like the ability to swipe to purchase on one of these items or something like that. There's lots of cool stuff you could do once you've got this. So this just really gives you that great interactivity with your customers.
David, I here again. I just want to show you a quick look at the part of the application that uses the department store fencing and also connects to the smart switch to turn the light on when the customer enters their favorite zone. And in this case, when they enter the breakfast cereal zone of the groceries department. So we have our user interface that can run on iOS and Android. And we've got a couple custom views there. We could use the master view as well. We've got a beacon fence component, and we've got the Vera AOTech smart switch component, which we'll use to turn on and off the light when we enter the breakfast cereal zone. Taking a look at the beacon fence map, we've got 4 different beacons that define our department, and we define the GUIDs and the major and minor values and the location, XY displacement of those beacons inside of the whole map. This is the map of the department store. We've got the toy zone, we've got a household goods area, and we've got a cereal area. And then we've got some path nodes. So as the customer walks around the department store, they can be guided to different zones or areas that they're interested in. And then on the beacon fence map, we set different properties, fencing option, map options, for example, to color the beacons, to highlight where we are inside of the beacon fence. And then we've got the particle filter, which lets us calculate where we are inside of the beacon fence as far as location is concerned. 2 of the events that we have hooked in this case, one is on zone enter and one is on zone exit. So if we enter the zone, first thing we're going to do is just see if we're in the cereal zone. And if we are, we're going to use the Vera AOTech smart switch. We're going to set the switch on property to 1, which will turn the light on. And then when we exit the zone, we're going to set the switch on property to 0, which will turn the light off. The rest of the code here will go into in a deeper dive later in June. And this code shows what's happening as we walk through with our iPhone app or our Android app. What happens is we're walking around the store, and we can even be guided along different paths. And now let's take a look at the demo in action using the beacon fencing and the ThingPoint, ThingConnect components that are part of RAD Server. Okay, the app is started, and now here I am inside of our department store walking in, and we're going to come near the cereal. The light comes on. We've entered the zone, and then as I move back and out of the zone, the light goes off again. Let's take a quick look at that one more time. I moved into the zone, and the light comes on. And then as I move out of the zone, the light will go back off again. And now I'm going to turn it over to Pavel Glavatsky. Pavel took the server-side RAD server, those BPL files, and he's put them in an Amazon EC2 instance so that we can run the same servers in the cloud. You can also install them on an Azure instance. Take it away, Pavel.
I have already connected to my remote machine using a remote processor, remote desktop connection. So on the server, there are 2 ways of deploying your server. So you can deploy it for development, for testing. So that is a standalone server that you can deploy to, or you can deploy to production, and in this case you would deploy your server as a Internet Information server application. So in the doc wiki on Embarcadero, you can see the list of files that you need to copy from your RAD Studio installation into your server application. So these are those files, and once you have these files copied, then you need to copy the files that are making up your application. So it's very important to realize that our application, our EMS server module is separate from the EMS binaries. So we are creating our EMS server as a EMS package, which is a BPL file. You can see inside my RAD Studio, when I create a new package, it is compiled as a BPL file. So BPL file cannot be run on its own. It needs to be run in a host. If we go into the project options, we can see that when we start this project, in fact we are starting the EMS dev server.exe, and then this is our host application, and it will load our BPL file. So on the remote machine we do not have RAD Studio installed, so then we need to copy the BPL files in a remote location. So in our case, in the case of our demo, there are two BPL files that I want to deploy. So I have copied these two BPL files into a specific location in my server. I have also copied the interbase database file that is used to store application data. And now I need to tell my server that these BPL files exist. So by default, in users public documents embarcadero./ems, there is an EMS server ini file that you need to edit in order to specify information about which BPLs to load on EMS server startup. So if we scroll down in this list, we can see that I have added just 2 lines in a server packages section. So this tells our server to load our packages. So if I now restart the EMS server, and the EMS server I have created a shortcut for it. So now if I just start a standalone server, you can see in the log that these two BPL files, you can see there is a BPL file EMS retail service, and there is a second BPL file get sale BPL loaded. So these two files are loaded, and our EMS server is waiting for incoming connection. So we can actually try out if this server is visible from outside of this remote machine. I can just go into my browser and just use one of the endpoints that are built in. So you can see that I can see my EMS service running and waiting for incoming connections.
As you can see, RAD Server is not only simple to use, but it's also simple to buy. You can license by the device, by a single site, or a multi-site, and we also provide a free 90-day evaluation.